Hi everyone, I'm Furkan and welcome to my new video series on game engine development. In this video, I'll be covering the basics of what makes up a game engine, setting up a development environment working with C++ code, and creating our first window using GLFW. Whether you're curious about game engines or interested in graphics programming, I'll be breaking down each step of the process. Let's see what we can build. We have computers, and with all this processing power, some of us want to simulate a virtual universe. In this virtual universe, we need observers to see and hear what's happening inside. For example, the term rendering is the composition of all techniques used for visually observing these virtual scenes. So, a game engine is a computer program that enables us to simulate, observe, and interact with a virtual universe. In the way of developing one, our first job is setting up the development environment. A developer needs to feel confident with the environment in order to become productive. If you're just starting with developing software, be patient, because it takes time to get used to it. Simply put, we need to write and execute code. I'm going to choose straightforward options: C++ for programming language, CMake for build system, and Conan for package management. Choosing the right tools is a bit of personal preference. So mostly, it's not that important at all, because with enough experience we should be able to replace any tool we're using at any time. To execute a C++ code, we need to make sure our computer has access to a compiler. I'm not going to mention step-by-step installation instructions here, since it varies between different operating systems, but you can find useful links to guides in the video description. You can use GCC with installing MinGW on Windows and Clang on macOS, and also GCC on Linux. Then we need to install CMake, which will help us organize the build process. You can follow the installation guides from the link in the video description. I'm also going to use VS Code for the code editor and ClangD for the C++ language server, which I highly recommend. You can install the ClangD extension directly from VS Code. This type of installation process can be really frustrating, and it's totally normal, so take your time and just don't give up here. The folder structure of our first program consists of 4 files: single C++ source file that contains a print statement, CMake lists file that defines the project name and which source files will be added to executable, gitignore file that defines which files are going to be ignored by the version control system, and finally a bash script file that helps us to run the CMake commands and run our project. On Windows, we can convert the bash script into a BAT file. With a successful installation, we should be able to compile and run our simple program by executing the build script from the terminal. This is our first and most important milestone in this journey, because now we have access to the whole processing power of our computer. From here, things are only going to get more exciting. Our goal is to simulate, observe, and interact with a virtual universe. Simulation is governing the whole data that represents our universe. For example, imagine a rock rotating around its own axis in the middle of nowhere. For physical accuracy, we also need a light source to see the rock. In this scenario, we can list all the data that makes up our universe. For the rock, we have properties like its shape, surface texture, position relative to the universe's center, rotation axis, and rotation speed. For the light source, we store its position and brightness intensity. For the visual observer, we have its position and viewing direction. We're also responsible for updating each physical property over time, which transforms our universe from a static snapshot into a living, dynamic system. Now we know how to represent an entity. Knowing our data will help us to develop a visual observer. Creating these systems requires good organization and workflow. I'm always looking for new ways to improve my productivity, and I found some good classes on today's sponsor, Skillshare. Skillshare is the largest online learning community for creatives, with thousands of classes led by industry experts. With learning paths, curated, sequential class collections, you can dive deep and master specific skills, taking your career or hobbies to the next level. Skillshare offers a wide range of creative classes, from digital art and illustration to graphic design, animation, film, and productivity. For example, Thomas Frank's Mastering Productivity class teaches you how to build a personalized productivity system to boost your efficiency and achieve your goals. The first 500 people to use my link in the description will receive a 1-month free trial of Skillshare. Get started today. Alright, let's get back to work and start creating our window. If we represent our visual observer as a camera, this means we need a canvas that is going to be filled with the information that the camera sees. To implement the canvas, we need a library that can create a window for us. We're going to use GLFW to create a window. Also, we need a graphics library to communicate with our GPU. OpenGL is a good starting point. It's a widely used library that allows us to send commands to our GPU, taking advantage of its parallel processing power. This will help accelerate our speed while painting the canvas. At this point, we're starting to use Conan for adding external libraries to our project. You can find the installation link in the video description for Conan version 2.0. Then we're adding a new file, which is a Conan file that defines which libraries will be used in our project. Also, we're going to update our build script file with the command for installing Conan dependencies. Lastly, we're updating the CMake list file to tell the CMake which libraries are going to be linked with our project. I also added a CMake flag to generate a compile commands JSON file in the build directory. It should be pasted into the root directory of our project to tell ClangD where the headers of build files are, and there is an optional Clang format file that describes the style of our code. Now let's update the source file to create a window using GLFW. Here's what we'll do. First, include the library headers and initialize GLFW. We'll define an error callback function and set it up to display any error messages during execution. Next, we'll set the window hints and create our window by specifying its initial width, height, and title. We'll get a pointer to this window and make it our current OpenGL context. After the window setup, we'll initialize GLEW, which provides access to OpenGL's graphics API functions. The main program loop will run until the window is closed, with proper cleanup occurring after the loop ends. Within the loop, we'll clear the window using colors that vary based on the elapsed time since program launch. Finally, we'll swap buffers and poll events to generate each new frame. When we execute this program, we should get a window, changing its color as time passes. We've successfully painted our canvas, marking our second milestone in this journey. After initializing a window to observe our virtual universe, we'll continue by understanding shaders and drawing simple objects onto our canvas. I hope this video can be a helpful resource for anyone navigating the challenges of game engine development. I published the code in a GitHub repository, so create a discussion there if you have any question or something doesn't work. Also, please let me know in the comments what could be improved in this video. Are there specific topics you'd like me to cover in future videos? I'd love to hear any kind of feedback. Thanks for watching. I'll see you in the next video.